Now we have to continue to design in the tab. We have to create a new model. In the model we create in a tab, not import from the S file. You can check for the how to design all the structure by using the F file from my previous tutorial. In this tutorial we have to create grid and create everything in a tab. Now you can select the metric SI and zero code. We select all the zero code, and you can create everything here from the beginner. But in the case I had to select my previous file. I want to import the material and everything from the previous file. I don't want to create it again. Okay, I just select my old file, so the previous data will be imported for the new model. Now we have to create the grid line. You have to check with your model about the grid line. In the case you have grid line, okay, in it 4 and 6, okay, 4 and 6. So you have to input it in the tab. Okay, 4 and 6. You have 3 in it direction or in y direction. You can add it the same, but in the case I had to create it as the custom grid. It is easy. You check here the backdoor side is the side at around the circle around A, B, C, and 1, 2, 3, 4. It is called a backboard side. You can increase or decrease it. And the grid system, okay, grid name, you can input your grid name. In this case you can display it as the grid as a coordinate, okay, put it as coordinate, or you put it as spacing. For easy to use, you have to input it as spacing. Okay, it's really easy to use because we not consider about relative coordinate. It's difficult to input. Okay, in this case we have relative distance. You can input it at a distance. The tab will automatically consider this distance in the model. Okay, you see here from the your model, this one is 4 meter and this one is 6 meter. Okay, now we just put the 4 and this one is the 6. It's the 6 you see here. Okay, A, B, C, and you check the grid in the here, A, B, C. Okay, it's the same. And now for the Y you have to input with the spacing the same. Okay, now in the case you see here, we have to extra more beam, so you have to consider the segment also. Okay, in the case we have to input it as the 3 meter. Okay, you can consider 3 meter. Okay, because in the middle it is span 3. Okay, this case 2.5. Now I have to input it. Okay, 3. Okay, 3, 2.5, 2.5. I add it more, 2.5. Okay, now you have complete this one, and this one is also 2.5. Okay, 2.5. Okay, 2.5, 2.5, and the last one is 3. Okay, it's 3. Okay, it's 3. Okay, now we have to complete for the grid line. Now you just click OK, and we have select on the grid only. And for the number story, you can specific number story. You have the ground floor, ground floor, first floor, second floor, and for the last one is the top roof. Now we have include it for the 1 and 2. We include it in the second floor. Now we have do not to the top roof because we don't know about the exact information. We have to delete it. Okay. The ground floor is 4.1 meter length, and first floor 3.6, and 3.6 is the same. Okay. In the case, you can take which one is master story. Okay, you can take here is the master story. So when you apply the load or your model, everything is the same with the second floor. Okay, you can display it by the color of the floor. In you it this floor as the color, and you can view its floor as a color. Okay, the option available when you display the color according to the story. Okay, now we have to continue by clicking OK. Okay, now you see here, you have to seal it. I seal it as the clinic structure design 22 to 2022 revision 0. Okay, now you see here in this option you can select all story, similar story. Okay, similar story, we define the master story is the second floor, and you select the option. When you take all stories similar with the second floor, we will automatically the same, apply the load, apply the structural element when you draw it the same. Okay, you can check your previous input about the master story. You can check here about the master story. Okay, when you take it the master story, and you can change it to similar to master story. So when you model your master story, the ground floor and first floor also model are the same, and when you apply load it the same, it according to the second story. Okay, now we have to select it the similar story. Okay, similar story, and we can create the floor for the ground floor, or everything will be automatically create the same for other floor. Now I have to create a new window view. Okay, it is 3D view. Okay, 3D view. Now we have to define about section, because I import from the previous file, the section automatically created, import from the all data. Okay, it is slab. Okay, slab. Now I have to create slab by using slab 12 centimeter, and I select it the similar story, and the plan I view on the second floor, the master story. Okay, you can draw it, or you can select it by use a quick floor. It is easy. You just scroll it here, you will got your slab. Okay, the slab. Okay, you see here. you see here. Okay, the structure will be but they are the same when you select the similar story. Okay, okay, now I want to put the beam. Okay, now let's start again by using beam. You can check the beam section you have or not. Okay, 4. Now we have to create about new beam section. I call it beam 50 cm. Concrete strength is 25. You can add your concrete strength from the import or add new material, and you import from the European concrete. You can add concrete what you want in here by clicking OK. In this case we have already the concrete strength here. Now we want to create another one. Okay, you can check here. Okay, the concrete strength we will add in the concrete in the material. Okay, now we have to select for the beam E25. Okay, 50, and this section is 20 multiplied with 50 centimeter. Okay, now we change it to 50, and we select the modifier. We design it as the beam, not design a column. In the case you select here design a column. Now the structure is beam. Now we have select it as a beam, and you have to import or input your rebar material. Okay, now in the case I had to import rebar material from the Vietnam because it's similar with my local area. You can add for the rebar, not for steel, because rebar we use in the concrete. Okay, DB20, DB16 it is rebar, and you can import material what you want. If you use Euro code, you can add the same. Okay, in the case you have add the rebar, and for other location you can add it. Okay, GB. Okay, for the rebar GB 500, okay, 500, 400, everything you can add from here. Now this is for the concrete cover. You can take it from here. Okay, now we have to draw the beam by using a quick beam. In this direction we use beam. Okay, beam 2050, as you can change beam other. You can change beam next time. Okay, now we just to try to use this beam dimension. Okay, and this is for the main beam. Okay, main beam we locate in the location main beam. So now we have to add for the main column. We have to define for the column again. Column we have to add new. Okay, C25 multiplied with 40 cm, and we start use from the concrete strength here, and we will verify it again about 480, 250. Okay, and we design it as column, and you can input the rebar material also. And for the case we have to design, not to check. If you want to check, you have to put everything in the same with your plan, and you can check the option to check the bearing capacity of the section. if pass or not. In the case we have to design for the rebar. Okay, we not specific about the layout of rebar, but in the case you have to check, you have to specific it the same with your section plan. It is very important. So in the case we have to design, it's not so important. Okay. Okay, now we have section. Okay. Okay, now I just select on the quick column. Okay, now you can see here it is our column position, this one, but you have to make sure your column is not in this direction. You have to rotate it. Okay, you have to rotate it. Select the quick column. You have to rotate it 90 degree. Okay, now we have to start again. Okay, now everything is the same with our concept. Okay, this one is correct, and this one is correct, this one is correct. Okay, now we keep dimension is the same, and we will optimize its later. Now we have to change this beam to other side. Okay, you can select it, you can select the sub beam and change it to the other section by assign frame section property. I select it to 220 and 30. You can take it. It's not pass, you can increase it. Okay. 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 Now you have to check about the plan layout. You can see here in the location you also has another beam, and you have opening for the stair. Okay, now I have to define its dimension. Okay, you can take it. Okay, now I have to correct the part. The location is here. You can check it the grid line 4. Now I have to change the grid line to easy to check with our method. This one is start with 1 is correct. It's not 2. We delete it. Equal 2. Delete it. It's 4. And you delete it. 5. Delete it. 6. Okay, another one is 7. You check it with the your AutoCAD is correct or not. Okay, if you need from the 6, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2. Okay, it is 3, it is 4, it is 5, it is 6. Okay, now everything is fine. Okay, you can check here. Now you have to put the opening for the stair. In the case you don't want, you can run it quickly, because you just want to get the 3 section, not exactly. Okay, not exactly. In the case you can add this beam. Okay, now I have to create it the same with the architectural plan. In the grid line 3, you have to add the opening. Okay, now let's start. 3 1 2 3. Okay, 1.1 by create draw join object. You input the direction is Z. Okay, Z 1 1 0 0. Okay, click 1, and from this is minus 1 2 0 from this one. Okay, now you have to create the opening by clicking opening, and you can click from here to here. Now we have to add another beam to create. You can add other location to create our opening. Minus 1000. Okay, from here. Okay, now we have to create opening. Click on opening and click from here and hold to the location. Okay, just drag it. Now you have to select this beam. It's scroll our stair. Okay, you have to select it. Delete. Okay, delete. Now in the location we have a stair, and we have to add other beam in the location. By create beam. Okay, select the section of beam. 20 30. Beam 20 30. 35. No, 35. We have to create new section. C beam, rear beam. Okay, add copy 300. B20 multiply 30 centimeter, and we design beam is correct. Okay, it correct. Now we have to create it. B20 cm. Okay, click here to here, and right click here to here again. Okay, now you see previously we add the rock section. It is a column. Now you can select it by this method, or you can do other method by using select property, or by using frame section. I select on frame C20 30 and select. Okay, you can change it to assign frame section 20 30. Okay, for the beam. Now we have changed it to the beam. Okay, now everything is fine here. Now we have to apply load in the ground floor. It is necessary to apply for the wall and for the slab load because you have soil to support. You can apply soil spring. In case you want to model it as a structure, you have to apply the soil spring for the ground slab, and the load will be automatically supported by the soil. Okay, in this case we have to apply from the first and from the second floor. Okay, now you see here the outside is brick 20. Okay, brick 20. Now you have to apply the outside parameter. Okay, now we have to select here, or you can to deselect dissolve the column by unclick column, and by unclick the floor we have to show only frame. Okay, in this case we select here, select here, select here, select here. We apply the assign load frame distributive. It is you can add other load, but in this case I had to include it in the load. The density is 16 kilonewton per cubic meter multiplied with thickness of the wall is 0.2 and multiplied with the height is 3.6. You minus the depth of beam is 0.5. 0.5. Okay, you see here it is the load on beam. We mark up with 210. Okay, okay, now you have to check it. Okay, the 10, and now you have to check about other location. It is for the parameter location 20 for the brick wall, and this one for the brick 20 brick T8 10 centimeter. Now you have to assign it one grid to one grid. Okay, by using here the same. In the case we apply in the location, in the location, and in the location. To check here. Okay, and the location we also have brick. Okay, now you have to assign it, and I have to assign in the location also 4 and 5. Have to check it 4 and 5. Okay, also have the brick. Okay, but in this time we have only 10 centimeter thickness of brick. Okay, so we have to divide it by 2. Okay, apply. Now load on beam we apply it already. Okay, you can check it again. And you can show the column and slab. Okay, you can extrude frame and slab. It do not show. You have to clear assign and select it again. Okay, it is your structure. Okay, now we have to input load of the stair. by using a load distribution. I click it. Now you have to check about your model, if it is clean or not. Okay, I will check floor by floor. What is different? Okay, indicate you can strike it by using this command and strike it. Okay, again. Okay, you can strike it. Okay, you have to make sure everything is fine before you analyze it. Now we have to review it again. Okay, now you have to click check your model, select all join and select OK. You have to make sure your model is no other error before you continue to analyze and design. Indicate your model has been checked with no warning and error. Okay, it is good right now. Now we have to apply for the stair load. Okay, for the stair load, we have to select it. We then want to show the column and floor. Now we have to select it and divide it. You select on command edit frame, divide frame, and divide with the object you select. Okay, so this one will be divided. Okay, now you have to select and apply the load of stair in here. Okay, assign, share, assign frame distributed. Now you have to select and apply it, the stair load on beam. So 11.2 multiply with 3 meter multiply with 24. Okay, 0.2 multiply it 3 meter multiply it 24. Okay, it is for the beam made here. Okay, 3 meter but it's not 3, it's 1.5, so you can shoot it for the stair. We apply the stair load. In the case Okay, your stair will be like this one. Okay, okay, it is your stair. Now we have to take this length and apply it for the beam at the top and the location. Okay, now we got the length is 3.1. okay, and the thickness of your stair is around 0.2. offset 200. Okay, we take this thickness, include for the load, for the extra load. Okay, so you check here. So it is correct. Now we have to apply it. Okay, now let's check for the load applied on the beam. Is correct or not? We have to take all the name of beam by select object assign and the section. Okay, now we have to check everything is fine. Okay, it's good concept right now. Load for the beam, and for the case we have to assign and clear assign, and we select on one story and we come back with the second floor. And in the case we have to show about the load, but we don't want to apply it the same, because at the top we do not have the brick. Okay, the brick wall. So in the case we assign it to frame distributed and we delete the load. Okay, and we select it for the one story only. Okay, so you can check your load and other story will be not deleted. Okay, because we change for the one story only. Okay, and now we still remain for the load. Now we have to delete the load also. We select assign and clear assign, and we select one story and we click on the load. Okay, we have to select this beam, okay, this beam, another beam, and we have assigned frame distributed, and we click on delete again. Okay, now we have to save it, and you check on your 3D model. Okay, your load now has only on the location and on the location. Okay, now we apply it the same with the beam in the location. We select it. We do not show about the opening. object assign share opening. We untick opening. We do not want to show about opening. And about the floor also. Floor, okay. Now we select it, and edit, divide frame, divide on select frame. Now we have to apply it the same, but the location of this one is okay. We want to move it to the location and apply it for the stair. Okay, plan again and again. Now I have to consider the stair is at this location. I select on edit, and you have select to move, because in the tab you do not have option copy and subtraction. You have to move it to the our height is 3.6 divide by 2, so you have to move to 1.8. okay, minus 1.8. you select similar story, and we have to apply. Now you have to check about 3D. Okay, now you have beam in the location. Okay, and after that you can copy it to the floor. Okay, you can select edit, replicate story, and to 1. Okay, now it is the same. Okay, and for the previous location we had to add beam. Okay, we had to add beam again. We have to check, because you just remove it, no beam. Okay, no beam. Okay, you can select it, edit, replicate, and to the story. Okay, okay, oh, now you can do that. So you have to material beam again. Okay, control Z. Control Z. Now you have to material beam again. Okay, I start from here and to here. Okay, now we have to select on plan again. Okay, remove it. After that you have to select it again and edit, divide frame. Okay, and you have to copy. No copy. Okay, it's now finished. You have to check your load again, it's correct or not. Okay, everything fine. Now we have to add other load in the location. Okay, select here, and assign frame distributed. Okay, now everything is fine for the load on beam. Okay, for the load on beam. Now we have to select on the floor plan and apply load on the slab. Okay, now you have to check here about your floor plan. We apply the load, we select it the similar story, and you can select do antique beam with the opening again. You want to show only the floor. Okay, and join, you have to untick it, and again you have to select it and assign say load uniform. You apply the load, the thickness, we take it 50 millimeter or 5 centimeter thickness for the concrete, for the tank, and for the mortar on the slab. So I take it 0.05 multiply density 22. Okay, 1.1 kiloton per square meter is applied, and for the line load we apply it to, we select from the previous select and apply it to. Okay, now you have to check it. We use it for the same because at the top rows we has other concrete roster, but we do not include it in the link, so you have to include it in the process. Okay, now you have to check it. Okay, you have to check it about the line load, the brick. Okay, you have to show about the beam, column, joint, and opening again. Okay, you see here, it is our brick. Okay, outside brick is brick 20 and inside is brick 10. Okay, and you check everything now is fine. Okay, and you check it again about first. Okay, now we has to get the load combination. I select here the zero code. Okay, define the load pattern, did load. Okay, you can apply bin load also. Load combination. Okay, everything is here, and we have to run check again to make sure everything is fine, no other error. In the case you want to apply below, you can apply on the second floor. Okay, now I have to correct it. By adding one floor. In this case, we had to delete load from the beam. We assign it only has assign frame distribution. We delete it. We delete from this one. We check with the media. Okay. Delete its row. Delete. And this one we keep it as divide by 2. Okay. Okay, we keep it the same. And we copy it to the below floor. Edit, replicate to the story one. Go to the best, to the story one. Okay. To select it and copy to story one. Okay. Now we have to add this. by divide the column by 2 and select beam. Okay, in the beam, and we add the same load. A 14.4 assign frame distributed 14.4. Okay, now let's start again. We have to start from this one. When you has D1 no has the load. Okay, and this one also don't has. Okay, it has. Okay, has this one. Now we have to run another second to check model again. Okay, now we have to perform analysis. Okay, now we have to check about circuit load again. Plan base. You see here, it is the circuit load when we apply the full floor with the same concept in the architectural plan. You see here the estimate load for circuit is 99, again 99 kilonewton, and you see here for the estimate is 90. Okay, 90. You can check, and for the ultimate is around 138 ton, and for your estimate is around 130 ton. Okay, you can check here. Now I want to apply the soil spring at this location. We have to assign, and we have to select, unselect, and you have to assign share, and we have to assign the other spring. Okay, you can modify it. Okay, this area spring conventionally is correct. Okay, and apply. Okay, now you have to run it again. We have to check about circuit load again. And we select plan at best. run it again. Okay, now we have to check about should we load again. Okay, now you see here that should we load is around here. When you apply for the load, now we have to make sure we apply load is the same. It's not. Okay, indicate for the ground floor, we have to apply for this one. Okay, for the location, A this one. Now I had to untick the floor and select this one, this one, this one, this one, this one. This one. And this one. In the location we skip it because we apply the load already. Okay, this one, this one, okay. Now apply assign load distributed, and we have to assign 16 multiply with 0.1 multiply with 4.1 minus 0.5. Okay, we have to apply it, and for the location we have to apply the load multiplied by 2. Okay, now we have to run it again. You see here in the column also apply load. Now we have to select it and assign the distribution. We have to delete the load from here. Okay, now we have correct that. I have to save it and run it again. you check at the best, and we check the reaction again. You see here, it is our predict is 85 down, is actual 85 down, and our predict is 90 down. Okay, 85 down, actual 85 down, actual, and for this one is 90 down for predict or estimate. Okay, for SLI you can check here. It is for the estimate for the circuit, and for the ultimate you can check ultimate load is 11 120 down, 120 down, and this one is 129 down. We has some variation between these two views, actual model. Okay, now you can check here what is the difference between the estimate and actual when we apply it there. Thank you for your watching. Thank you.